Hello everyone, and welcome back to the lab. It's your host, Banatani. Wow, what a wonderful morning. Today is Monday, November 24th, 2025. I hope you all had a fantastic weekend. Today, I found a super interesting article in the archives that I just have to share with you all. It's from the world of which, as you know, is all about machine learning. Alright, let's get our thinking caps on. The title of the paper is Revolution Strategies at the Hyperscale, and the URL is charts:/stack.org/abs/2511.16652. Phew, that's a long one. But the name of their new method is, EGGROLL. Isn't that a fun name? That sounds delicious. But this EGGROLL is a recipe for making AI much smarter. So okay everyone, let's dive in. What problem is this paper trying to solve? Well, think about how we usually teach big AI models. The most common way is called backpropagation. It's kind of like being a very strict teacher. You give the AI a problem, it gives an answer. You calculate the exact error and tell precisely how to fix every little mistake. All the way back through its thinking process. It works really well, but it can be slow. And it needs the problem to be a certain way. But with that's easy to measure those little mistakes. Now there's another way to teach, called evolution strategies, or S for short. Imagine a big classroom full of students, which we call a population. Instead of teaching just one student, you give all of them the same problem, but you let each one try to solve it in a slightly different way. Or you look at all the answers, give a high score to the students who did well, and use their successful ideas to guide the whole class for the next problem. This is amazing because all the students can work at the same time, which we call parallelization. There's a big problem. When you're working with today's giant AI models, which have billions of parameters, using evolution strategies is like having to print a completely unique giant textbook for every single student in your classroom. Can you imagine that? The amount of paper, or in this case, computer memory and processing power, is just enormous. It's so expensive that it's basically been impossible to use this method for the biggest size. And that's where tasty sounding friend EGGROLL comes in. EGGROLL has a super clever idea. Instead of giving every student a brand new giant textbook, what if we just give them a few sticky notes with small changes? This is what they call a railway dictate, which way cheaper and faster. The paper says this method gives a 100-fold increase in training speed for these huge models. 100 times faster. That's like going from walking to fly in a supersonic jet. It makes evolution strategies practical for the super-duper big AI models of today. And here's the really neat part. Even though each student's sticky note only has a small change, when you combine the best ideas from thousands of students, the overall lesson learned is still very rich and complete. So you get all that speed without losing the quality of the education. So you might be wondering, how does this help us in our daily lives? Well, let me give you a few examples. First, imagine smarter and more creative AI assistants. Right now, teaching a large language model, like the one in your favorite chatbot, to be good at complex reasoning like math or logic, is really hard. With EGGROLL, we could train AI to be an amazing math tutor. Instead of just correcting its wrong answers, we could have thousands of versions of the AI, all trying to solve a tricky math problem. The ones that find a good solution path get a high score and the AI learns from them. This is perfect for tasks where there isn't just one right way to do things, making the AI more flexible and even more creative. Second, this could help us build completely new kinds of computer brains. This is my favorite part. The researchers used EGGROLL to train a language model that works purely with integers, whole numbers like 1, 2, and 3, instead of complicated decimals. This is a huge deal. Why? Because integer math is way faster and uses much less electricity on computer chips. Imagine the AI on your phone and your smart speaker being incredibly powerful, but barely using any battery. This has been super difficult with traditional methods because they can become unstable. But because EGGROLL doesn't need to calculate those exact little mistakes, it can handle this pure integer training with no problem. This could lead to a future of super effective AI. And for a third example, let's think about better robots and self-driving cars. A robot learns to walk, or a car learns to drive, through a process of trial and error called reinforcement learning. Evolution strategies. We're naturally really good at this. EGGROLL makes it possible to use this powerful technique on the massive AI models needed for these complex tasks. You could have thousands of virtual cows in a simulation, all trying different ways to navigate a busy intersection at the same time. The cows that get through safely and efficiently get the highest scores, and their strategies are used to improve the main drive of AI. This could help us develop safer and more capable autonomous systems much faster than before. So, how does EGGROLL compare to other technologies we might have heard of? Well, compared to the standard method, Backpropagation, it's a completely different philosophy. Backpropagation is that one-on-one tutor calculating every exact mistake. EGGROLL is more like a massive brainstorming session. It's better for problems that are messy and noisy, or where the only feedback you get is simply, but worked and worked. We might also think this sounds a bit like another technique called LoRa, which also uses a low-rank height idea. That's a great connection to make, but here's the key difference. LoRa is like an efficiency tool that you add on to the standard Backpropagation method. EGGROLL, on the other hand, completely replaces Backpropagation. It uses the low-rank idea as a core part of its evolutionary search process. It's a whole new way of teaching, and finally, compared to older evolution strategies, the difference is simply scale. Older methods couldn't handle the giant textbooks of modern AI. EGGROLL's sticky note trick is the key that unlocks the door to the Hyperscale era for evolution. So to wrap it all up, EGGROLL is a really exciting breakthrough. It takes a powerful and flexible, but previously too expensive, method for training AI and makes it practical for the biggest models we have today. It's like giving an old, reliable teaching style a brand new, supercharged engine. Isn't that just fascinating? It shows us there are always new and clever ways to help our AI friends learn and grow. That's all the time we have for today, everyone. Thank you for joining me. Stay curious. Bye-bye.